Antarctica, the most isolated continent on Earth, holds 70% of the world's fresh water. Its immense ice sheets are crucial to global climate stability. Below this frozen expanse, vast unexplored regions await, revealing clues that could transform our understanding of life on Earth and beyond. Encompassing a frozen landscape of towering glaciers and vast ice sheets, Antarctica stands as a formidable force in the global climate system, shaping Earth's weather patterns while remaining a world untouched by human presence. Here, nature's most extreme elements reign supreme. Winds that can reach over 300 kilometers per hour. Ice sheets that stretch beyond the horizon. And an isolation so complete that it feels as if the continent itself is suspended in time. Frozen in perpetual stillness. Its vastness and remoteness make it a place few will ever experience. Yet its importance to the planet's survival is immeasurable. The Antarctic ice sheet, covering an area of over 14 million square kilometers, is by far the largest mass of ice on the planet. This frozen sheet holds around 70% of the world's fresh water, playing a pivotal role in regulating the planet's temperature and influencing global weather patterns. It acts as Earth's natural air conditioner, helping to regulate the planet's climate by reflecting sunlight back into space. This albedo effect cools the planet, preventing it from becoming too hot. Without this reflective ice shield, Earth would absorb far more heat, raising the global temperature and accelerating the effects of climate change. However, Antarctica is not just a place of extremes in terms of cold and ice. It is a continent of contradictions. Despite its massive ice sheets, it is considered a desert in its own right. Antarctica receives less than 2 inches, 5 centimeters of precipitation annually, making it the driest place on Earth. The majority of this precipitation falls as snow, which further accumulates and compacts into the thick ice sheets. There is little moisture in the air, and even during summer, when the continent experiences 24 hours of daylight, the atmosphere remains cold and dry. This lack of water defines the harshness of Antarctica's climate, and in turn, it makes it incredibly difficult for life to take root here. Despite the severe conditions, Antarctica is not as barren as it might seem. It's home to a small but resilient collection of life forms that have evolved to thrive in the planet's harshest environment. From penguins and seals to krill and microorganisms, life has found a way to survive against the odds. Yet, even these hardy creatures face an uncertain future as the climate shifts and the ice begins to melt. In recent decades, the effects of global warming have begun to show. Sea ice that once covered large areas of the continent is retreating. Impacting the food chain and altering the delicate ecosystems that thrive in Antarctica's frozen waters. Penguins, for example, are among the most iconic creatures of Antarctica. The emperor penguin, the largest of its kind, breeds during the harsh Antarctic winter. These penguins are uniquely adapted to the extreme cold. They huddle together in tight colonies to stay warm, with each penguin taking turns in the center of the group to shield the others from the brutal winds. Yet, even these resilient birds are facing challenges. Sea ice is essential for the penguins' breeding and foraging. They rely on the ice to give birth and raise their chicks, as it provides a stable platform for breeding. However, with the ice melting earlier in the season, many colonies have found themselves without reliable breeding grounds. Some penguin populations have seen a decline of up to 50% in recent years as the ice retreats. Similarly, seals like the Weddell seal and crab-eater seal depend on stable ice flows for breeding and haul-out sites. As the ice shifts and shrinks, these seals are forced to find new breeding grounds and haul-out sites. Leopard seals, predators in the Southern Ocean, are also affected by the changes in the ice as their feeding grounds change with the movement of the ice shelves. The dramatic changes in sea ice have a cascading effect on these animals' ability to find food, raise their young, and survive in the harshest of climates. Beyond the marine life of Antarctica, the ice itself holds more than just water. It holds ancient records of Earth's past. The ice sheets contain layers of compacted snow that have accumulated over millions of years. Each layer serves as a snapshot of the atmosphere at the time it fell. These ice cores are some of the most valuable tools for understanding the planet's climate history. Scientists drill deep into the ice to extract these cores. which contain air bubbles that trap gases like carbon dioxide and methane. By studying the gas concentrations in these bubbles, scientists can reconstruct past climate conditions and better understand the natural cycles that have shaped the Earth's climate over time. Some of the ice cores drilled from Antarctica date back more than 800,000 years, providing a time capsule of Earth's climate. These ancient ice cores show us the changes in the Earth's temperature, the concentration of greenhouse gases, and the natural climate fluctuations that occurred long before industrialization. But they also offer a stark warning. In the past century, carbon dioxide levels have increased rapidly, reaching concentrations never seen before in Earth's history. This rapid increase in greenhouse gases has led to the warming of the planet at an unprecedented rate, and Antarctica's ice is showing the signs of this change. The West Antarctic ice sheet, one of the continent's largest ice masses, is melting at an accelerating pace. Recent studies have shown that the rate of ice loss from Antarctica has tripled since the 1970s. This is a troubling sign that the continent is undergoing rapid changes that could have far-reaching consequences. Ice shelves that once stood as immovable barriers between the land and the ocean are breaking apart, and glaciers that have been frozen for millennia are retreating at rates never before recorded. The Thwaites Glacier, sometimes referred to as the Doomsday Glacier, holds the potential to raise global sea levels by as much as 3 meters if it collapses entirely. If the West Antarctic ice sheet were to collapse, the effects would be catastrophic for the world's coastal regions. Low-lying countries and cities such as Maldives, Bangladesh, and Miami would face the real threat of flooding. Entire communities could be displaced, leading to a global refugee crisis. But even before the complete collapse of the ice sheets, the melting of Antarctica's glaciers has already begun to contribute to sea level rise. As the ice melts, it flows into the oceans, raising the water levels and affecting the world's coastal ecosystems. In addition to the loss of ice, Antarctica's glaciers also play a significant role in the carbon cycle. The Southern Ocean, which surrounds Antarctica, is a crucial player in absorbing carbon dioxide from the atmosphere. The melting of ice in Antarctica affects the circulation of the ocean, disrupting the natural processes that have helped regulate Earth's climate for millions of years. As fresh water from the ice sheets flows into the ocean, it dilutes the seawater and affects the ability of the ocean to absorb carbon dioxide. This, in turn, contributes to global warming and accelerates the warming of the oceans. Yet, despite all these challenges, Antarctica remains an incredibly valuable resource for scientists. It offers a unique opportunity to study the effects of climate change in real time. With research stations dotted across the continent, scientists from around the world continue to gather data on everything from ocean temperatures to ice dynamics. These data are crucial for understanding how the planet's systems are changing and how we can best mitigate the impacts of these changes. As the ice reveals ancient landscapes and hidden ecosystems, new mysteries emerge. Beneath Antarctica's frozen surface, powerful forces like ice quakes and tectonic activity are quietly reshaping the land. Revealing that this continent is far more dynamic than we once thought. Antarctica is often perceived as a frozen, still land, a vast, icy wasteland where time seems to stand still. But beneath the frozen surface, forces of nature are at work that contradict this image of stillness. Beneath the ice sheets and beneath the surface of the land, ice quakes, earthquakes, and even active volcanoes shape the landscape in ways that are still being studied by scientists. These natural phenomena, once thought to be distant or insignificant in the context of Antarctica's frozen wilderness, are increasingly revealing the dynamic and living nature of the continent. Antarctica is not just an ancient relic of a frozen past. It is alive, constantly changing and evolving. One of the most mysterious and least understood phenomena in Antarctica is the ice quake. Often described as an earthquake beneath the ice, an ice quake occurs when a large section of glacier or ice shelf moves rapidly or cracks, releasing immense amounts of energy. These events are the result of the immense pressure building within the ice as it slowly moves toward the sea. It's not just a simple shift in the ice, it's a dramatic release of energy that causes the land to shake and reverberate for miles. Scientists have discovered that these ice quakes are much more common than previously thought, especially as the ice sheets continue to melt and shift in response to global warming. The primary cause of these ice quakes is the ice flow within Antarctica. Large glaciers and ice shelves, such as the Ross Ice Shelf and the Filchner-Ronne Ice Shelf, are constantly moving. As the ice sheets move, they exert pressure on the land beneath, causing cracks and fissures to form. These cracks eventually release energy in the form of seismic waves, similar to the tremors caused by earthquakes. The energy released during an icequake can be massive, capable of being felt hundreds of kilometers away. This shifting is not just a matter of ice flowing. It's a dynamic process that involves immense forces being exerted on both the Earth's crust and the ice itself. The result is a powerful, often unexpected release of energy, which is why scientists have focused so much attention on monitoring icequakes. While icequakes themselves are primarily the result of shifting glaciers and ice sheets, earthquakes in Antarctica are also a significant source of seismic activity. Earthquakes in Antarctica are not as frequent or as intense as those in regions like the Pacific Ring of Fire or along the San Andreas Fault, but they still occur with surprising regularity. The West Antarctic Rift System, a series of tectonic faults beneath the West Antarctic ice sheet, is the primary region where these earthquakes are most likely to occur. The rift system is essentially a giant crack in the Earth's crust, formed by the forces of plate tectonics that pull the Antarctic plate away from the surrounding plates. This movement of tectonic plates causes seismic activity, earthquakes, that shake the continent. One of the most notable features of Antarctica's earthquake activity is its low-frequency seismicity. Most earthquakes in Antarctica are relatively small compared to those in more seismically active regions, but they are still powerful enough to affect the movement of the ice sheets. The movement of tectonic plates beneath Antarctica causes small tremors which, over time, can influence the flow of the glaciers and ice shelves above. As the crust moves, the pressure on the ice sheets increases, causing them to either shift or fracture. These seismic events can also influence the ice's interaction with the ocean, potentially speeding up the melting of the ice shelves or triggering calving events where large chunks of ice break off and float into the sea. These movements beneath Antarctica's icy surface also provide insights into the continent's geological history and its role in Earth's broader tectonic processes. Antarctica is located at the South Pole, and its position at the center of the Southern Ocean makes it a unique point of interest for scientists studying continental drift and the movements of tectonic plates. The tectonic plates beneath the continent are slowly shifting, and though they may not cause large earthquakes, their gradual movement can lead to significant changes in the landscape over millennia. The study of earthquakes and seismic activity in Antarctica, while still in its early stages, offers clues into how the continent's ice sheets may behave under future climate scenarios. And how the land beneath is adapting to the changing climate. Perhaps the most unexpected and dramatic natural force in Antarctica is the presence of volcanoes. Antarctica, despite its icy appearance, is home to some of the world's southernmost volcanoes, many of which remain active to this day. As scientists continue to study the volcanoes in Antarctica, they are uncovering more about the continent's history and the dynamics of the Earth's crust beneath the ice. The relationship between volcanic activity, earthquakes and icequakes presents an opportunity to better understand how the tectonic forces beneath the surface can influence the movement of ice sheets and glaciers. These findings are particularly significant in light of global warming and the rapid ice loss occurring across the continent. If the volcanic activity beneath the ice increases, it could lead to further destabilization of the ice sheets, increasing the speed of ice loss and contributing to rising sea levels. Antarctica's natural forces, earthquakes, icequakes and volcanoes, are not isolated phenomena. They are interconnected elements of the continent's larger geological processes, each one influencing the others in ways that are only beginning to be understood. The increasing seismic activity in the region, combined with the volcanic heat beneath the ice, creates a delicate balance that shapes Antarctica's environment. These natural events are not just geological curiosities. They have profound implications for the planet's climate. Sea levels and ecosystems. As Antarctica's ice shifts and tremors, shake the land, one thing is clear. The forces beneath the surface are only just beginning to stir. What will happen when the ice finally gives way?